Hi everyone, this is an instructional walkthrough for the first lesson of week 4 geospatial, working through the RMD called Get Spatial. Now there's a few new packages we'll need for the geospatial week. They've been added to the setup script in the repo already, so you should be able to start your session by running sourcing the setup script. We're also going to set our TMAP mode to view to make some quick interactive plots. So this first section is walking you through vector data and how you can import vector data with the Tigris package. And this is similar to some stuff we did in week 1 spatial lesson. Now instead of working with roads, we're working with a different linear feature, pulling in linear water features for just Larimer County. And when you run this, it might take a little while to download. And once this is done, we'll notice that this new linear feature is pretty large. There's a lot of linear features. So what we're going to do is first, when you inspect this data frame, we're going to look at some of the metadata of the variables. Let's check out linear features here. And so we notice a trend in full name. Let's sort this here. All of them have a common ending if they're a creek or a river or a ditch, etc. So for this example, say we just want to filter out the linear features categorized as river. So with this, we can use stringer detect from the stringer package. And from this, we want to pull out all features where full name has RIV in it. Okay. And again, I'm walking through this a little quick, but I hope you spend time reading through all of this text in these lesson plans in addition to these videos. These videos are some supplemental to what this lesson plan is working through. And so this lesson for week 4 is building off of iteration techniques you learned in week 3. Particularly in this lesson, we're working more with for loops and mapping with the per package. So if you haven't worked on week 3 lesson in a little while, I would definitely recommend going back to that and also watching the videos where you're introduced to for loops and mapping with the per package. So next steps, we're going to pull in some more spatial data. This RGBIF package connects to the GBIF database, which is a global species occurrence database. Last time I checked, it had over 2 billion records in it. And it returns the data as point data, so as longitude, latitude. For this lesson, we're going to look at some charismatic Colorado species. We're interested in looking at elk, marmots, and western tiger salamanders. So from this RGBIF package, there is a function called occurrence_data. So this is a function that is a part of the package. You don't need to create this function. And this function, you give it a species name and it pulls all of the occurrence data in the database for that species. I'll get to in a second. There's a lot of cleaning steps you can add within occurrence data. Let's just say we want to look at those. Let's open up the help pane for occurrence data. We have a breakdown of this function, and then all of these arguments you can add to further filter what occurrences you are downloading. So there is a ton. And then there's specifics of what argument is specifically pulling and filtering. So what I did here is first, we want to import data for our 3 species. So I've made this species vector with the scientific names because the occurrence data function searches by scientific name, not by common name. So we have the scientific names for elk, marmot, and salamander. And then second, we want to make a string for common name because we are going to use these common names more often for plotting and filtering, etc. And so it's important that we make this common name vector these species are in the same order as their scientific name in the species vector. Okay, so what exercise 1 wants you to do, there's some tips to getting started here I recommend paying attention to, but what I did here is I wrote down the workflow outline, so you don't need to spend much time trying to construct this data pull code yourself. I did all of that for you. But in this example, I'm showing how I would do that for just one species. And so here at the beginning, I am just pulling out the first scientific name and the first common name of the species and common name vector. Let me make sure I ran that. Okay. And then I'm showing the process of how you pull the occurrence data. So you give it the scientific name, which since this is the first element, this is going to run just for the elk species. We give it a geometry, so we only want to filter occurrences within a specific region. And this you have to make sure you have the county's shapefile imported from earlier on in this lesson. And so we're telling it to only import occurrences within counties, so this would be the bounding box of the state of Colorado. And some of these species have a ton of occurrences, so you can set a limit. For this lesson, we're just going to limit it to 2,000, so we're not working with a huge data set. And let me show you quick. I'm going to set species and common name to just the first element, so now species is just elk. And then when I run this, it might take a while, but you'll notice it returns a list. And it's a list of metadata and a few other things, I think, but we only want the data frame. And so what this is doing is piping just the data frame. So this element here returns a data frame, and we see from this preview some of the few variable names, etc. Second, I'm creating a new column for each element in this data frame to add the common name, because we want to work with the common name later on in the analysis for this week. And then third, I'm further cleaning this same data frame. I just want distinct coordinates. There's a lot of duplicate coordinates in GBIF records sometimes. And then there's a ton of columns, so I'm just going to select these columns that we need for further analysis. So this is the process of just doing one iteration for elk. What this exercise is asking you to do is to convert this into a for loop. So it's going to perform the occurrence data function along with all this associated cleaning for each species. So what you'll want to do is get rid of this. This was just my example of showing you how I would run it for one species. And we want to work with these 3 species vectors. And then in these hints here, you'll need to, if you remember in the for loop lesson, we need to create an external vector because each iteration of this for loop, so this whole chunk will go inside a for loop, and each iteration we'll want to save it to an element of that external empty list that we create, so it's not getting overridden in every iteration. And then in the end, we'll have a list of 3 data frames, but we want just one, and so we can bind rows of that list object you created. So those are some tips and guidance for working through exercise 1. This is just getting a little deeper into the syntax of for loops, so you don't need to edit any of this raw code. I just want you to convert it, so add a few lines of code that will make it a for loop that will run over all of our 3 species and common names. And then there's a challenge here to do the same thing, but instead of a for loop, iterate it using your knowledge of per map. Okay, now next is working with SNOTEL data with the soil DB package. These snow telemetry stations have daily snow depth across many sites in the U.S., but we're interested in just the ones of Colorado. And specific in this example, we're going to pull SNOTEL sites just in Larimer County. So when we run this, we are pulling the SNOTEL metadata file, and we're telling it which package to pull it from. So when you install the SoilDB package, it comes with this metadata file. When we run this, we now have this metadata data frame that gives us information about each individual SNOTEL site. This is important because we need the site ID in the site column to pull the SNOTEL snow depth data, and we'll also want to tie it back later to get latitude and longitude so we can plot each site on a map. And so there's one exercise here about filtering the metadata just to Larimer County and then convert it to a spatial object and naming it SNOTEL sites if you want to follow the next exercise verbatim using the same object name. So similar to the exercise with the for loop, I've written out the line of code that would pull SNOTEL data for one site. And now for exercise 3, instead of converting it to a for loop to iterate across multiple sites in this case, I want you to use per map to iterate the SNOTEL data pull for each SNOTEL site. So, and there's some steps here again to help you get started. This here, I'm showing you how I'm pulling out the first site ID from the SNOTEL sites metadata we just created in exercise 2. And then this line of code is the string of operations you would do to pull. So we're pulling daily snow depth data from each of these sites in Larimer County for the year 2020 to 2022. And again, you don't need to edit this code at all. I've worked through the process of pulling this SNOTEL data and cleaning it. But now you will want to put this chunk of code, instead of creating just one data frame for one site, you'll want to put this within map and map across all unique sites in the SNOTEL site using the site column. And again, go back to lesson 3 and those videos with lesson 3, week 3, to refresh yourself on using iteration with the per map functions. Okay, and then this first half is importing vector data. So we now have polygons, lines, and points. And we want to save all these so we can use it in the future spatial lessons. So we're saving these 4 objects as an RData file. If you need a refresher on what RData files are, that was covered in the week 1 material. But if we save it all as RData, it'll save all these environmental variables, and then in the next lessons we can load these RData files back in and it'll put these environmental variables back in our environment. Okay, second half of this lesson is working with raster data. Exercise 4 is kind of telling you to build off of, so remember in the week 1 spatial lesson, which you should go back to refresh yourself again, we walked through importing elevation data for the state of Colorado, and this is telling you to do that again. And then along with importing the data, naming your file elevation.tif, if you want to be able to follow the code verbatim in the next lessons, cropping it to the extent of Colorado, giving it the name elevation. Again, all of these steps you've already done back in week 1 spatial lesson. And then to answer this exercise, make a quick plot. This can be static, interactive, whatever, but include a plot in this assignment to show that you have in fact imported elevation for the state of Colorado and you cropped it to Colorado. And then last is some land cover data that is already included in this repository. We don't need to pull it in separately. I've already downloaded it and cleaned it. But you'll notice that it has this auxiliary file. This is in the data folder. And we'll see we have both a TIFF and then also a tiff.aux.xml. So what I want you to do is read in this NLCD Colorado raster file, which you can do with the Terra package. Let's just call it NLCD for this example. We'll do rast data NLCD. And when you're reading in these raster files, you call the TIFF file, not this aux file. But I want you to read this in and inspect this raster and how you think that this question is asking, what do you think this purpose of this auxiliary file is, and compare this to how the elevation data is formatted and saved.